So our next speaker, Mark Pitts, is the Vice President of Enterprise Informatics, Data and Analytics at Highmark Health, which Highmark Health is the third largest integrated healthcare delivery and financing system in the United States. Mark has over 25 years of healthcare experience in both payer and provider organizations. In his 7 years with United Healthcare, Mark built the UHC data science function from the ground up, including the creation of an innovative and award-winning data and analytics platform. And he actually helped pioneer the application in machine learning and unstructured data analysis to meet some very intense healthcare challenges. He's a sought-after public speaker on the subject of public healthcare analytics, regularly appearing at events throughout North America and around the world. So we're very happy to have him with us today. So at this point, I will turn it over to Mark Pitts.
Well, thank you, Ryan. I appreciate that. Thanks to each of you for taking time out to listen to what I have to say this morning. Now I have to live up to that introduction. So we'll see how I do. It may suck, but I'll try not to make it boring. So I'm going to start out by talking a little bit about big data, which you've all heard enough about today, and it's a term I've come to despise over time. But I think we need to address it a little bit, and then we'll talk about really the theme that I'll carry through this is the human part of data analysis, right? We talk about platforms and tools and Hadoop and software and algorithms and statistics and all those things, but we forget the human creativity that's involved in doing this type of work and doing it well. So that'll be a theme as we go through. And then of course we'll talk about how something backfired on the Minneapolis Police Department, and I got to be the guy to help it backfire on them. But so we'll come to that. So the big data challenge, you guys have all heard this before, blah, 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 volume, the scale of data. You've all seen that IBM statistic there. 90% of the data in existence in the world today was created in the last 2 years, and that statistic's about 3 years old at this point, I believe. Analysis of streaming data is what I think of when I think of velocity. I like that. 420 million wearable wireless health monitors in use by the end of the year. That's a lot of streaming data. And that's just those little things around people's wrists, right? Different forms of data. 85% of data is unstructured. This is a special area of interest for me. Things like medical chart notes, nurse notes, doctor's notes, things that are not leveraged highly today in the healthcare analytics space. And then finally, the reliability of data, veracity. So when I work in the healthcare space, and when you're making decisions about people's healthcare, you want to make sure the data you're using is reliable. But it's not just that. So let's go back to that human factor for a moment. Who in here has heard of Abraham Wald? Does that name ring a bell? All right. We have one guy in the back that knows who I'm talking about. Have you ever heard the story of the missing bullet holes? So he's probably read a book about it, right? So Abraham Wald was a statistician and mathematician that worked for the United States government during World War II. He was in New York City. And he was tasked with a problem. He said, they asked him to say, hey, where should we put the armor on these aircraft? Okay, and they gave him a data set. They counted the bullet holes in all the planes that came back from bombing missions over Germany. And they asked him to help them understand how to optimize the armor on these planes. They'd done an initial analysis, my understanding, and they had come back with, you know what, we need to put armor on the wings and the fuselage and all that. The problem was the data set was incomplete because actually those bullet holes were associated with survivability. Because the bullet holes that hit the engine, the plane didn't come back, and those weren't in the data set, right? So human thought and human creativity and human problem solving is central to what we can do with these types of data. So data is the new oil. There are a lot of different ways to say that. There's a previous speaker that had a different quote for that a little bit longer. But for me in the 21st century, data is how we're going to make the economy move. Now, this is Foreign Affairs magazine. I'm a fairly eclectic guy. I like to read a lot of different things. And I was really looking forward to the arrival of this magazine so I could read about something other than big data. Maybe something going on in the Middle East or, foreign policy, et cetera, et cetera. And this shows up, right? Really? Big data. So it's become ubiquitous, right? So the true meaning of big data for me is really three things. It is from n equals x less than all to n equals all. And by that I just mean using all the data instead of just a sampling of the data. Traditional statistical techniques are built for sampling. They're built for small data sets, right? The new data that we're dealing with, highly dimensional, very wide data, very large data sets, those techniques don't work as well. From clean curated data to messy raw data. So we have to be really good at working with data that's not as clean as we might be used to in an enterprise data warehouse. We have to develop techniques for doing that. And then finally, the move from causation to correlation. I call this our addiction to causation. We are always trying to find the causal relationship between an effect and a cause, right? And that's important, but we need to be willing to act on correlation. And my seminal example of that is a study that was done at the University of Toronto, where they connected the telemetry information from preemie babies to some machine learning algorithms, to put it over in an oversimplified fashion. And they were able to predict 48 hours in advance which of those babies would develop a fever and an infection. And they were able to apply prophylactic antibiotics and prevent that infection. Did they know what in those signals was causing that? No, but they were willing to act on the correlation. And that is another part, I think, of this big data equation. Now here's where we hopefully start to get a little more interesting. So the creepy factor, who's heard of this one? Right? Okay, a couple of folks. I used to live in Minneapolis. Target is based in Minneapolis. This is a Target story. I actually know the guy that did this analysis. So for those of you who aren't familiar with it, there was a gentleman that called up a Target store who was very upset. He said, why are you guys sending my daughter advertisements for diapers and other things related to her having a baby? She's 16 years old. Cut it out. So the Target manager said, we'll take care of that, sir. A few weeks later, called him back and said, sir, have the mailing stopped? Is everything okay? He said, well, you know, there were some things going on in my house I didn't know about, and my daughter is actually pregnant. And Target knew about it before he did. One of the reasons they were able to do that is they had a database of baby gift registries, and so they had a database of people they were able to associate. They knew that they were pregnant, they knew the due dates, and they knew what their purchasing patterns were and how they changed over time. So not only were they able to predict that you were pregnant, but they were able to predict your due date. Things like, for example, women tend to change, my understanding, from scented to unscented lotions at a particular point in the pregnancy. So that gives you a marker to, from there, measure, you know, when the baby is due. So imagine the marketing you can target with that kind of thing, and no pun intended. The iPhone challenge. Now, this is another one I like to do. I'm about the only speaker in the world that will ask you to pull out your iPhone if you have one, if it's running a later release of iOS, because Siri's watching you. Okay, so if you were to pull out your iPhone and go to settings, and drill down through privacy and location settings, you would finally get to the point where you can see that there's a log of every place you've visited for the past few weeks or months. And it'll even plot it on a map for you. So I looked at mine a little while ago. I've been to my house 95 times in the last couple of months, 2 or 3 months. So that sort of makes sense. But if you don't want people to know where you've been, your phone's keeping track of it, whether you like it or not. The other thing I'll say, do you share photographs online? Most of the people in this room probably know this, but a lot of phones are defaulting to set up to include the GPS coordinates of where the photograph was taken. Okay? So, you know, for example, a predator online, if your 16-year-old daughter is posting, you know, pictures, they can not only tell where you live, but potentially even what room of the house she stays in. So this kind of data is out there. Now, this can backfire on you, because I had a friend whose phone was stolen. And the guy who stole it was posting pictures online. He had pictures of his house, all these things. I said, hey, buddy, go pull down that picture, pull up the GPS coordinates, and you know where he lives, and you'll get your phone back. He says, no, I turned that off. So it works both ways. He tried to protect himself, and it ended up backfiring on him. Now, let's get to the heart of this. So the MPD, Minneapolis Police Department, installed automated license plate readers. Now, agencies all over the country are doing this. An automated license plate reader is essentially a special camera that can read a license plate. It can read it at 120-mile-an-hour closure rate. It can read multiples very quickly. It'll automatically check against a wanted database. So if there's a hit for a stolen car or a car that's being wanted for any other reason, it'll alert the officer in the car. It also tracks, it keeps a database of those hits over time. So every license plate that it reads, it records. Now, MPD had those deployed on patrol cars, parking enforcement vehicles, and other things, as well as having cameras in secret locations. Now, some of these locations weren't so secret because you could see the camera on the pole, but there were some, they wanted to keep the locations of all these hidden cameras secret. But there was a catch. So in Minneapolis and Minnesota at the time, there was a privacy law, and essentially a sunshine law, if you will, that all of these data were public. So you could actually go and request, hey, give me all the hits for my license plate or whatever. I was one of 8 or 9 people or organizations who requested the entire database. So I got 90 days worth of every single license plate read that was done in the city of Minneapolis by these readers. People were very concerned about their privacy. You know, there's a big public debate about this. You know, Big Brother is watching me, and maybe my boss can go downtown and figure out that I wasn't really sick that day, I was at the bar, all of these kinds of things, right? People are concerned about their privacy, so I decided I'm going to get a hold of this data set and do an analysis myself. So here you see a histogram of every read over 3 months. This is several 100,000 plate reads. by readers. So you can see they had a few readers installed on mobile vehicles. And you'll notice missing, which is the largest component of these. Those are the stationary cameras. Okay, so they redacted the reader ID as well as the GPS coordinates of the read, but everything else was still there. And you can see weekly fluctuations in traffic patterns. You can see Thanksgiving over there where traffic dropped. So basic descriptive statistics. Here's another interesting visualization. If you're familiar with the city of Minneapolis, that's a great street map of Minneapolis. That is every read that occurred in those 3 months colored by reader, excluding, of course, the stationary readers because they didn't know where those were. So you can see they had pretty good coverage. Now, the data showed that any particular individual had very little to be concerned about. There were very few plates that were read more than 3 or 4 times over that 3-month period. So nobody's going to be looking over your shoulder with a read rate like that, right? Most of the vehicles that were tracked more than that were police vehicles themselves. So they were parking in the police parking lot and they're reading the other police license plates and so forth. And the other interesting part about this is they're wrong 10% of the time. So it has a hard time distinguishing between an I and a 1 and an L, for example. So they're fairly high rate of error on these things. The police, however, had a great deal to be worried about. So let's think about what this is. You've got public information, right? So I can get every single one of these license plate reads. Unintended consequences. So as I told you, they redacted the data to protect their stationary cameras, but I was able to use that data to find the cameras anyway. Now when I called, as soon as I did this and I realized, okay, hey, I can do this, somebody else might be able to figure this out too, I sent an email to the people at the Minneapolis Police Department and I said, hey, I figured this out. Hey, by the way, here are the locations of your hidden cameras, just so they knew I wasn't crazy. And you would have thought I'd dialed 911 because in 2 minutes my cell phone was ringing. It was a public information officer from MPD calling me, asking me how I did that. They thought they had a data breach. They'd accidentally forgotten to redact something. And for some reason, when he found out you needed to be a statistician or a data scientist to figure this out, he wasn't as concerned. I guess I don't have too many criminals, but I would think if there's a criminal with that skill set, you might want to be more concerned about that guy. But hey, you know, we'll get there. So how did I do that? Now, for a long time, I didn't tell anybody how I did this because the data was public and I didn't want to compromise the locations of the police cameras if they didn't want them to be known. But the data is no longer, probably within a few days of this analysis, the mayor of Minneapolis actually requested that the data be made private. That request was granted and the legislature went on to make the data private. So these are no longer available. Let me back up for a second. So the data includes plate number, the lat long of the read, the date and time of the read, and the reader ID code for the mobile cameras. Okay? For the stationary cameras, they redacted the lat long and the reader ID. I was able to find it anyway. And it had nothing to do with some fancy statistical analysis. It just had data manipulation. It was a very large data set. You had to be able to work with distance data, lat long, and so forth. Here's the key insight, right? And this is not rocket science, but every time I tell somebody about this, 95% of the time they say, Mark, I would never thought to do that. Well, okay, good. That's part of the cool part about this. It's the human creativity again, right? The problem solving. How did I do that? MPD forgot that their mobile readers sometimes drive by their stationary readers and hit the same plate within the same period of time. So here you see an example of that. So on the top you see a stationary reader, it hit that license plate at that time. And there's the mobile reader that was driving by the stationary reader and hit the same plate. Okay? There's the camera, or something very close to it. Now, the data, 1 minute, 2 minutes, 3 minutes, between those simultaneous reads or near simultaneous reads. If you plot them on a map, here's one set of cameras. Okay, this is actually 2 cameras, and I'll show you where they were, or where they are actually. The center of that is a bridge going across a river in Minneapolis, and the red colors are further distant in time. So red is like 3 minutes apart, the medium blue color is 2 minutes apart, and so forth. So if you plot that out, and you take basically the mean of that distribution, it turns out that those cameras are located on the Broadway Street Bridge. And I know there are 2 cameras there, one because I drove out there and looked, but the other's because they're directional. So there's actually one on that pole pointing that way and one on that pole reading every car that goes that way. Okay? So you can imagine the police weren't really too happy about that. But I didn't publish the locations of the camera. I just published that I had found the locations. I showed a couple of reporters that I had done it and how I did it, and so they were willing to publish without telling people how I did it and so forth. But wait, there's more. Okay, it gets better. So these things actually act as virtual trackers. So think about this. These cars are driving around town And every plate they read, they're recording the time and the location of where that car was. So you can see things like patrol patterns and timing. You can see individual officer behavior. You can see when and where they eat lunch. Okay? You can learn a lot about the police by this. I can tell you how to get in and out of the city of Minneapolis without ever hitting a license plate reader. I can tell you when to do it, how to do it, what routes they take, and so forth. And you can do some fairly interesting analyses. So let's say you wanted to look at one police car. Okay, how does that particular car patrol over a period of time? You can actually take the different tracks from different days and plot them by time. So if you wouldn't mind flipping to that video. So this will reset in a second. Well, the thing I wanted to show you, the lower right-hand corner, it's hard to read, but that's a time index. Each one of those tracks is the same car, and it's labeled with a date. Okay, so that's where that car was going. The size of the bubble is the number of plates it was reading at that location. Okay, so there we're starting again. This is about 7-something in the morning. This particular car starts its patrol typically around 8:30. So when we get to 8:30, you'll see an explosion of tracks out of the same location. Okay. This is pretty interesting. He's stuck in traffic on September 14th heading north. You can see that sort of move up a little bit and then move up a little bit further. So I guess cops get stuck in traffic too. Okay. But imagine the types of analyses you could do with these. And there are many other agencies around the country that have many, many more cameras than Minneapolis. Okay, Boston, for example, almost have one in every corner, from what I understand, in every police car. So there's a lot of information, there's a lot of analysis you can do. I chose this one particularly because it's not informative of anything. It's the guys all over the place. So if you want to flipping back to the slide. So there was the video. And then finally, coming to the end, you can tell when and where they take their breaks. But there's one more insight I wanted to share with you about the Minneapolis Police Department that I learned from this data. And that would be that 10:15 on Thursday morning would be the wrong time to rob Donut Land. Okay. So with that, that's my presentation. Thank you. I'm willing to take any questions you might have. Hope you enjoyed it. No questions. There's one. Let's wait for the microphone.
So I'm interested that the way that they solve that problem is they just hid the data. So it's not that they're still collecting the data and they can still do all these things.
They can.
Just nobody else can.
And the ACLU, actually, as part of this, I get interviewed by the press. I talk to people at ACLU and so forth. And they're very up in arms about how these data are retained. Most people are okay with the police using this technology to do things like, is this a wanted plate as he's driving down the road? What they're concerned about is keeping these reads in a database that could then be used to go back and track somebody or sort of be big brother. There are multiple arguments to that. You might not find out about a crime for a week or two. Then you might want to go back and see who was in that area at that time. So there's a public safety issue with this, and that's opposed to a privacy issue. So we have to figure out, I think, how to use this technology and these data for the greater good without endangering individual privacy.
How long are they keeping it now?
As far as I know, it's still 90 days. But that varies by agency around the country. Some, I think, keep it forever. Some keep it for 48 hours.
I'm just curious, since you've done this, have any other similar types of situations arisen or that you've become aware of with other data being collected by agencies or others that might create that sort of a vulnerability?
There have been some news reports, and in various areas of the country. California comes to mind. There was an article written in the Wall Street Journal. There have been some TV news reports around these types of data, but nothing quite like this. Nothing where somebody like me was able to get a hold of the entire data set and do something cool with it like this. But it is an issue around the country because this technology is becoming more ubiquitous. I mean, as you drive down the road, you might even be able to see these on police cars or on poles, or if you're driving in the state of Pennsylvania and you go through the rapid toll lane, whatever it's called here. I just moved here a few months ago. There are license plate readers shining down on you as you go through.
Where was the best restaurant?
In Minneapolis?
Yeah, that they all ate at.
Oh, Donut Land, of course.
No. Could you figure that out?
Oh, probably, yeah. I mean, there were places, there were times when I could see, they'd met at the hospital after a traffic accident. There were times when they, went to the barbecue restaurant or whatever. I've kept all of that confidential, but, not like you couldn't see the police cars outside, but, yeah. What else? All right. Well, thank you. Appreciate your time.